Hello friends, I welcome you in lecture number 23 on relations. In this lecture we are going to discuss about graph of a relation. We will see how we can draw the graph of a relation, and it is very easy to draw the graph of a relation. First we will understand the method of drawing graph of a relation with the help of one example, and then we will discuss in general how to draw the graph of a relation. Suppose I have one set having four natural numbers 1, 2, 3 and 4, and here we have one relation defined on this set A, that is we are having subset of A cross A, and we want to draw the graph of this relation R which is defined on a set A. Now to draw the graph of a relation, we must have a finite set, and our relation is defined on a finite set. So we will have finite number of elements in a given set. To draw the graph of any relation, first we have to see that what are the elements or members in a given set A on which our relation is defined. Here we have four elements or members in a given set A. Now first thing we have to do is, whatever number of elements are there in a given set, we have to represent those elements either by points or circles in this way. You can draw this type of small circles, or you can consider points also. Here I am having four elements, so I represent those four elements by this type of circles 1, 2, 3 and 4. So this point or small circles are known as nodes of a graph. We can see that here there are four nodes 1, 2, 3 and 4. So the number of nodes in a graph is equal to number of elements in a given set on which our relation is defined. Nodes are also known as vertices. Vertex is another name for node, and if we have more than one node, we will write vertices, plural of vertex. So this is the first step in drawing any graph. First you have to find out the vertices or nodes of the graph, and the number of vertices is equal to number of elements in a given set. Now once you draw vertices of a graph, another thing you have to consider is how many ordered pairs are there in your relation. So for each ordered pair, we will consider, for example, suppose we consider this ordered pair 1, 3, which is an element of a relation R. So to represent this graphically, I am having 1 related to 3. 1 is related to 3 by the relation R. So I have to draw an arc from vertex 1 to vertex 3. I am having vertex 1 here, and here I have vertex 3. So to show that 1 is related to 3, I will draw an arc from 1 to 3. And because 1 is related to 3, to represent this, I will consider this type of arrow which shows the direction that 1 is related to 3. So if some element is related to another element, we will draw an arc from this element to this element, and we will mark this type of arrow on that arc. So this arc is called edge in the graph, EDGE. It is called edge. So there is an edge from 1 to 3 because 1 is related to 3. So if 1 is related to 3, we will draw an edge from 1 to 3 pointing towards 3 because 1 is related to 3. We can consider this also. Here 2 is related to 4. So in a similar way, we will draw an arc or an edge from 2 to 4 pointing towards 4. Now here 1 is related to 1. So whenever our element is related to itself, we will start from that element and we will come back to that element. So we can show the arrow either in this way or in this way. It does not matter because 1 is related to 1. This type of edge which starts from element and ends at that element itself is known as loop. Loop is an edge which starts with an element and it ends with that element. Or we can say that whenever we have some element is related to another element, for example here 2 is related to 4, then there is an edge from 2 to 4 pointing towards 4. So here this 2 is called initial vertex and this 4 is called terminal vertex. So if these two vertices are same, then there will be a loop like this. So this is the way how we can draw the graph of a relation. We have to draw the vertices and edges which represents ordered pairs in the given relation. For every edge there is an ordered pair in a given relation R. So for each ordered pair we must have to draw an edge in this way. 1 1 belongs to R, therefore there is an edge from 1 to itself. 1 3 belongs to R, therefore there is an edge from 1 to 3 pointing towards 3. Now 2 is related to 1, so we have to draw an edge from 2 to 1. So here I have to consider this direction. There is an edge from 2 to 1 because 2 1 belongs to R or 2 is related to 1. Similarly 2 is related to 3, so I have to draw an edge from 2 to 3. 2 related to 3. Then 2 is related to 4. Here 3 is related to 1. So here I have to consider this type of edge. 3 is related to 1. 3 is related to 2. So there is an reverse edge from 3 to 2. 2 is related to 3, therefore there is an edge from 2 to 3. And 3 is also related to 2, so there is an reverse edge from 3 to 2 and here arrow is in the direction of 2. 3 related to 2, that means there is an edge from 3 to 2 pointing towards 2. And 2 related to 3, so there is an edge from 2 to 3 pointing towards 3. Then last one is 4 1, ordered pair 4 1, so I have to draw an edge and 4 is related to 1, so my arrow is in this direction. So this is the graph of a relation, and here direction is important because whenever we consider 2 related to 3, then I have to draw an edge starting from 2 ending at 3 pointing towards 3. And 3 related to 2 means I am going in this direction. And here we can see 2 is related to 1. 2 is related to 1, but 1 is not related to 2. So here direction is important, this arrow is important. If I am drawing an arrow in this direction, that means 2 is related to 1, that is 2 1 belongs to R. And if I forget the direction and if I am considering this arrow, then I am making a mistake. If I am considering direction in this way, that means 1 is related to 2 or 1 2 belongs to R, but here 1 2 is not in R. So be careful, this arrow is important. Arrow shows the direction, and that direction is important because if A is related to B, then it is not necessary that B is also related to A. So to show that A is related to B, we are considering an edge starting from A and ending at B, and we consider this arrow to show that A is related to B. If B is related to A, then arrow will be in this direction. So this is the method of drawing the graph of a relation. Again I repeat, first we have to find out the number of elements in a given set. Suppose I have m elements, say x1, x2, xm in a given set, then I have to draw m vertices. After drawing m vertices, I have to find out the number of ordered pairs in a given relation. Suppose I have ordered pair xi, xj in a relation R. If ordered pair xi, xj belongs to R, then I have to draw an edge starting from xi and ending at xj. If xj is also related to xi, then I have to draw an reverse edge. Reverse edge or reverse arc from xj to xi, but it is not always necessary that you will have reverse edge. So in this way we can draw the graph of a relation, and because here directions are important, this graph is called directed graph. Graph of a relation is known as directed graph because here directions are important, and short form for directed graph is diagraph. So whenever we are talking about graph of a relation, we are talking about directed graph or diagraph. And here I have written the description for graph of a relation. A relation can also be represented pictorially by drawing its graph. Suppose we want to draw the graph of a relation R, which is defined on a set having m elements. Then first thing is we have to represent elements of x by points or circles, and they are known as nodes, or another name is vertices. So first step is to represent elements of a given set by points or circles, and we will call those points or circles as nodes of a graph or vertices of a graph. After that, the nodes corresponding to xi and xj are labeled xi and xj respectively. That is, if I have a, b, c, d as elements in my set A, then I will give this same label. Here A is in set A, so I will represent this node by A, this node by B, and this node by C, and this node by D. So we are going to use the same notation to represent nodes. If I am having alpha, beta, gamma, then here I will write alpha, beta, gamma. That is the meaning of this remark. The nodes corresponding to xi and xj are labeled xi and xj respectively, and these nodes may be called as vertices. Another name for node is vertex. Now once we draw the nodes or vertices, we have to find out that which ordered pairs are present in our relation, or which elements of a given set are related via given relation R. If xi is related to xj, that is, if ordered pair xi xj belongs to R, then we connect nodes xi and xj by means of an arc and put arrow on the arc in the direction from xi to xj. This we have already discussed. If xi is related to xj, then we have to consider an arc, and we put an arrow on this arc in the direction from xi to xj. When all the nodes corresponding to the ordered pairs in relation R are connected by arcs with proper arrows, we get a graph or directed graph of the relation R. If xi is related to xj and xj is also related to xi, then we draw two arcs between xi and xj. Xi is related to xj, xj is also related to xi, then we have to draw two arcs from xi to xj and xj to xi. And if we don't want to draw two arcs between xi and xj, then we can consider this type of thing also. Okay. Xi is related to xj as well as xj is related to xi, then we can show two arrows. If we don't want to draw two arcs, then we can draw one arc between xi and xj, and we can put two arrows on this arc. So that I have written here. For simplicity, we may replace the two arcs by one arc with arrows pointing in both directions. So that is what I explained here. If xi is related to xj, xj is related to xi, and if you don't want to draw two arcs, then you can draw only one arc, but you have to put two arrows pointing in opposite direction. Now if some element is related to itself, that is xi is related to xi, then we get an arc which starts from node xi and returns to node xi. Such an arc is called a loop. So here I have drawn several arcs representing this discussion. Okay, here there are two vertices, and x arc is starting from x and ending at y, and arrow is in the direction of y. This means x is related to y. Here our arc is starting from x and ending at x, so this is loop at vertex x. Here we have two arcs, x is related to y, so there is an arc from x to y, y related to x, so there is an arc from y to x. And here you can see I have three nodes x, y and z. So there is an arc from x to y, that means x is related to y. There is an arc from y to z, so y is related to z, and there is an arc from z to x pointing towards x, so z is related to x. Here we have an arc from x to y, that means x is related to y, and we have an arc from y to itself, that is y related to y. So in this way we can sketch the graph of a relation, and whatever we have discussed, from that we conclude that graph of a relation consists of two things or two sets. One set is set of vertices or set of nodes that we denote by capital V. Another set is set of edges. Edge means an arc between two vertices. So graph of a relation is nothing but set of vertices and set of edges together make the graph of a relation. So if they ask you to write down the definition of graph of a relation or directed graph or diagraph, you can write in this way. A directed graph or diagraph consists of a set V of vertices or nodes together with a set E of ordered pairs of elements of V called edges or arcs. So this is the definition. Directed graph consists of two sets. One set is set of vertices together with another set, which is the set of ordered pairs of elements of V called edges. And we can write that for any edge, if I have ordered pair AB, then there is an edge from A to B. So I can consider ordered pair AB to denote edge. So if there is an edge from A to B, then the vertex A is called an initial vertex of the edge, and the vertex B is called terminal vertex of that edge. So this is all about diagraph or directed graph of a relation, and we will continue with graphs of a relation in upcoming lecture. I hope you like this lecture. Thanks for watching.